So let's take a look at the idea of taking a derivative of something of the form of b to the x, where b is a base other than e. Now, d dx, the first derivative of b to the x, is the same as d dx of e raised to the x ln b. That's because, as we said earlier, b to the x is defined as e to the x ln b. So once I think of it in this form, I now know how to take the derivative, because we know how to take the derivative of something in the form of e to the g of x, some function of x. So this is going to actually be equal to, this derivative will be equal to e to the x ln b times x ln b prime. That's how we took the derivative of something of the form e to the g of x. But the derivative with respect to x is going to be ln b for this part. So this is just going to be, whoops, got ahead of myself a little bit, ln b times e to the x ln b. But remember, we said this is what b to the x is. So this whole thing is going to be ln b times b to the x. So this is the derivative of b to the x. So let's take a look at a couple of examples here. Based on this, I know the solution right away is going to be the log of the base. So that's going to be ln of 3 times 3 to the 2x plus 1. But I forgot I need to take the derivative of this piece right here. I can't lose track of that guy. So I'm going to end up with, when I take the derivative of this, I'm going to have a 2 out here. So there's my solution. Now, let's write it in this form so we can actually see truly where this comes from. 3 to the 2x plus 1 is equal to e raised to the 2x plus 1 times log of 3, the natural log of 3. These two are equivalent. So now let's take the derivative of this, just like we would normally take a derivative. So d dx of this thing, let me slip it in there. The derivative of this is going to be itself times the derivative of the exponent. Well, the derivative of this with respect to x, ln 3 is a constant, so if I multiply it through, I have 2 ln 3x plus ln 3. So when I take that derivative, I will get 2 ln 3. So I end up with this derivative being equal to 2 ln 3 e to the 2x plus 1 ln 3. But this is nothing more than 3 to the 2x plus 1. So this derivative is 2 ln 3 times 3 raised to the 2x plus 1, which is exactly what I wrote just a moment ago, simply by looking at this pattern and applying it here. Okay, another example here, I have 2 cosine x. I want the derivative of 2 cosine x. Well, again, I'm going to write that as e to the ln 2 times cosine of x. So I want the derivative of this. So that's going to be itself, e raised to the ln 2 times cosine of x times ln 2 cosine of x prime, the derivative of this, because this is my g of x. Well, the derivative of this is going to be negative ln 2 sine. So this derivative is going to be a negative ln 2 times sine of x times e to the ln 2 cosine of x. But remember, this is just 2 to the cosine of x. So this is going to be a negative ln 2 times sine of x times 2 to the cosine of x.